The next curve that we're going to study is the hyperbola. It's another one of the conic sections or slices of a cone. But it turns out you've actually already studied and graphed a hyperbola. We just didn't refer to it as a hyperbola. So, for some review here, let's take a look at y equals 1 over x. Way back when we studied this curve, it was called the reciprocal function. We also took a look at this function when we studied rational functions because it's also a rational function. And if you remember, it's characterized by having asymptotes. It has a vertical asymptote. It also has a horizontal asymptote. And the reciprocal function has one branch in the first quadrant and another branch down in the third quadrant. We call it an odd function because it has origin symmetry. But it turns out that this function could also be classified as a hyperbola. So take a look at the shape of this graph because this is a hyperbola. Hyperbolas are going to have two branches. So we'll say it has one branch here, for this example, in the third quadrant, and another branch up here in the first quadrant. And hyperbolas are also going to have two linear asymptotes. Incidentally, this particular hyperbola is one that has been rotated. In this chapter, we're going to be more interested in taking a look at hyperbolas that either have one branch opening to the right and the other opening to the left. This is what we're going to refer to as a horizontal hyperbola. Or we'll take a look at hyperbolas that have one branch opening up and one branch opening down, which is what we call a vertical hyperbola. So we'll take a look at the horizontal hyperbolas first. So it's important that we all speak the same language and have the same vocabulary with regard to the hyperbola's characteristics. So this first graph is an effort to all get on the same page about the anatomy. So I'll show you in a little bit how to actually find the asymptotes, but for right now I'd like you to just go ahead and graph a line that passes through 0, 0 that has a positive slope, and because it is an asymptote I'll graph it as a dotted line, and then also graph a line that has the opposite slope as this one that also passes through 0, 0. So I'm just freehanding in two asymptotes. So to create a hyperbola, we're going to be able to figure out the asymptotes, which we'll do in a little bit. Then we'll travel a distance away from the center. So the center in this particular case is 0, 0. So I'm traveling a distance to the right, and that distance that I travel to the right is what we're going to call our A value, if it's a horizontal hyperbola. So we're going to travel this distance, and that's going to get us to a point which we'll label as the vertex. So just like in ellipses, where A was the distance from the center to the vertex, it's the same in a hyperbola. So A will always be your distance from center to vertex. So we could travel, in this example, to the right, a distance of A. We could also travel to the left, a distance of A. And that's going to get us our two vertex points. And then our hyperbolas are going to be nice and smooth curves that are going to approach the asymptotes. So I'll have one branch here that opens to the left, and another branch over here that opens to the right. So this would be an example of what we call a horizontal hyperbola. And A, again, A is the distance here from center to vertex. So this line that connects the two vertex points, if I were to draw the line that's connecting the vertices, it goes through the vertices, it also goes through the center. This line is what we call our transverse axis. Transverse. So we have a horizontal transverse axis because of the horizontal line here, which is what creates the horizontal hyperbola. One branch is opening to the right and another branch is opening to the left. So now let's take a look at what we call a vertical hyperbola. So we'll begin the same way in talking about a vertical hyperbola. A is still going to be the distance from center to vertex, but we'll start by just drawing in, freehanding in, two asymptotes. Again, one that has a positive slope that passes through 0, 0, and then one that has the opposite slope that also passes through 0, 0. But now, if your hyperbola is vertical, then you'll be traveling from the center, you'll travel up. Try that again. Here we go. We're going to travel up. There we go. Up a distance of A, and that's going to give us our vertex, and then we'll go down that same distance of A to get to my other vertex. So once again, I'm going to have two vertex points. We'll call them vertices. And then the branches of my hyperbola will simply pass through the vertex and approach the asymptotes. Sorry for that delay. Here we go. All right, so it's nice and smooth, passing through the vertex and approaching the asymptotes. And these are my two branches, one that opens up and one that opens down. So this is what we consider a vertical hyperbola. And if we were to connect the two vertices, notice that that line segment would also pass through the center. And this creates a vertical line, and this is what we call our transverse axis. So if you have a vertical transverse axis, then that means that your hyperbola branches are opening up and down.